Beneath the frozen surfaces of distant moons like Europa and Enceladus lies a mystery that could redefine our understanding of life in the universe. These alien oceans, hidden under miles of ice, are not just vast and unexplored, they're teeming with possibilities. What if the key to unlocking their secrets isn't a human explorer, but an artificial intelligence? Today, we're diving into how AI is revolutionizing our ability to explore these icy worlds, pushing the boundaries of what we thought was possible in space exploration. From robotic probes to advanced algorithms, we're on the brink of discoveries that could answer one of humanity's oldest questions. Are we alone? So, what could AI reveal beneath these alien oceans? Let's find out. Imagine a world where the surface is a frozen wasteland, but just beneath lies a vast, hidden ocean, warm, liquid, and possibly brimming with life. This isn't science fiction. It's the reality of icy moons like Europa, Enceladus, and Ganymede. These distant worlds orbiting gas giants like Jupiter and Saturn are some of the most fascinating places in our solar system. But how do these subsurface oceans even exist in the first place? The answer lies in a delicate dance of forces. Tidal heating, caused by the gravitational pull of their massive parent planets, creates friction within the moon's cores, generating enough heat to keep water liquid beneath miles of ice. Add in geothermal activity and chemical interactions, and you've got the perfect recipe for a potentially habitable environment. But here's the kicker. These oceans aren't just pockets of water, they're global, stretching across entire moons. Europa's ocean, for example, is thought to be twice the volume of all Earth's oceans combined, and Enceladus, it's spewing plumes of water vapor and organic molecules into space, giving us tantalizing hints of what might lie beneath. These moons are prime candidates for extraterrestrial life because liquid water, energy, and organic compounds, the building blocks of life, are all present. Exploring these environments, however, is no easy feat. Temperatures plunge to hundreds of degrees below zero, pressures are crushing, and the ice layers are miles thick. Sending humans is out of the question, and even robotic probes face enormous challenges. That's where AI comes in. Unlike traditional systems, AI can adapt to unpredictable conditions, analyze vast amounts of data in real time, and make split-second decisions, capabilities that are crucial for navigating these alien oceans. From autonomous underwater drones to advanced algorithms that can detect signs of life, AI is the key to unlocking the secrets of these icy worlds. So, what might it find? The possibilities are as vast as the oceans themselves. So, how exactly will AI help us explore these alien oceans? The answer lies in a suite of cutting-edge technologies designed to tackle the extreme challenges of these icy worlds. At the forefront are autonomous underwater drones, equipped with AI systems that allow them to navigate through dark, icy crevices without human intervention. These drones are built to withstand crushing pressures and freezing temperatures, using advanced sensors to map the ocean floor, detect chemical signatures, and even search for signs of life. But it's not just about hardware. Machine learning algorithms play a crucial role too. These algorithms can sift through massive amounts of data in real time, identifying patterns or anomalies that might indicate something extraordinary, like microbial life or hydrothermal vents. Take NASA Europa Clipper mission, for example. While it won't dive into Europa's ocean directly, it's packed with AI-driven instruments that will analyze the moon's surface and plumes of water vapor. These tools will help scientists pinpoint the best locations for future missions to explore, potentially guiding robotic probes to areas where life is most likely to exist. And it's not just about Europa. Missions to Enceladus and other icy moons are also leveraging AI to enhance their capabilities. For instance, AI can help robotic probes make split-second decisions, like avoiding hazards or adjusting their course based on new data, something that's critical when you're millions of miles from Earth. But what could these tools actually discover? The possibilities are staggering. Imagine an AI-powered drone detecting a cluster of microbial life thriving near a hydrothermal vent, or a robotic probe uncovering complex organic molecules that hint at the building blocks of life. These discoveries wouldn't just answer the question of whether we're alone. They could reshape our understanding of biology itself, and then there's the potential for the unexpected. What if AI uncovers phenomena we can't even imagine, like entirely new forms of life or geological processes unlike anything on Earth? The beauty of AI is that it's not just a tool for exploration, it's a partner in discovery, capable of seeing patterns and connections that humans might miss. As we push the boundaries of what's possible, one thing is clear: AI is revolutionizing how we explore these alien oceans. But the real question is, what will it find when it gets there? The answers could be closer than we think. But how does AI actually detect signs of life in these alien oceans? It all comes down to biosignatures, chemical or environmental clues that could indicate the presence of living organisms. Think of it like a cosmic detective story where AI is the sleuth piecing together the evidence. One of the most promising biosignatures is methane. On Earth, methane is often produced by living organisms, and its presence on icy moons like Enceladus has scientists buzzing. AI can analyze the chemical composition of plumes erupting from these moons, looking for patterns that suggest biological activity. For example, if methane is found alongside other organic molecules like hydrogen or ammonia, it could be a strong hint that something is alive beneath the ice. But here's the tricky part: not all methane is created equal. It can also be produced by non-biological processes like chemical reactions between water and rock. That's where machine learning comes in. By training AI on vast datasets of known biological and non-biological processes, scientists can teach it to spot the subtle differences. For instance, AI might analyze the ratio of methane isotopes variants of the same element to determine whether the gas was likely produced by microbes or geological activity. It's a bit like teaching a detective to tell the difference between a natural gas leak and a campfire. And methane isn't the only clue AI is hunting. On Europa, hydrogen detected in the moon's icy crust could be another piece of the puzzle. If AI finds hydrogen in combination with other chemicals, it might suggest hydrothermal vents, underwater geysers that could provide the energy and nutrients needed to support life. These vents, similar to those found in Earth's deep oceans, are hotspots for microbial activity. AI could help map these environments, identifying the most promising areas for further exploration. Of course, the challenge isn't just finding biosignatures, it's interpreting them correctly. The line between biological and non-biological processes can be razor thin, and AI has to navigate this complexity with precision. For example, on Enceladus, AI might detect a plume rich in organic molecules, but is it evidence of life or just the result of chemical reactions? To answer that, scientists are developing AI systems that can analyze multiple data points at once: chemical composition, temperature, pressure, and more, to build a clearer picture of what's happening beneath the ice. So, what might AI discover about the origins of life in these alien oceans? The possibilities are as vast as the oceans themselves. Imagine AI uncovering a thriving ecosystem of microbes near a hydrothermal vent, or detecting complex organic molecules that hint at the early stages of life. These discoveries wouldn't just tell us if we're alone, they could reveal how life begins and evolves in the most extreme environments, and who knows? AI might even stumble upon something entirely unexpected, rewriting the rules of biology as we know them. The search for extraterrestrial life is one of humanity's greatest quests, and with AI as our guide, we're closer than ever to finding the answers. But how do we even begin to map these alien oceans hidden beneath miles of ice? It's not like we can just send a satellite to snap a photo. That's where AI steps in, combining advanced imaging technologies with its ability to process and interpret data in ways that were once unimaginable. Picture this: a robotic probe equipped with sonar and radar systems descends through the icy crust of Europa. As it penetrates the frozen shell, it sends out pulses of sound and radio waves, bouncing signals off the ocean floor and ice layers above. These signals are then captured and analyzed by AI, which stitches together a detailed, three-dimensional map of the subsurface environment. What makes this process so groundbreaking is AI's ability to handle the complexity of the data. Traditional systems might struggle with the noise and interference caused by the ice, but AI can filter out the clutter, revealing the hidden contours of the ocean floor, the flow of underwater currents, and even pockets of thermal activity. Think of it like turning a blurry, out-of-focus image into a crystal-clear map. This isn't just about creating pretty pictures, it's about understanding the dynamics of these alien oceans. For example, by mapping thermal vents, AI could help us identify areas where life might thrive, as these vents could provide the heat and nutrients needed to sustain ecosystems. And it's not just sonar and radar. AI can also enhance other imaging technologies like LiDAR, which uses laser pulses to measure distances and create precise topographical maps. On icy moons, LiDAR could help us understand the thickness and structure of the ice shell, revealing cracks, fissures, and even potential entry points for future missions. Combine this with AI's ability to analyze chemical data from plumes or ice samples, and you've got a powerful tool for uncovering the secrets of these hidden worlds. But why does this matter? Beyond the thrill of discovery, mapping these oceans is crucial for future exploration and even potential colonization. Knowing where the currents flow, where the thermal vents are, and where the ice is thinnest could guide us to the most promising areas for landing probes or setting up research stations. It's like having a treasure map for the cosmos, one that could lead us to the ultimate prize, evidence of extraterrestrial life. So, what might these maps reveal? Imagine uncovering underwater mountain ranges, vast plains, or even deep trenches that rival Earth's Mariana Trench. Or perhaps AI could detect patterns in the currents that suggest a dynamic, ever-changing environment teeming with activity. These maps wouldn't just satisfy our curiosity, they'd pave the way for the next generation of missions, guiding us to the most exciting and scientifically valuable locations. And who knows, they might even reveal something we never expected, opening up entirely new questions about the nature of these alien oceans. With AI as our cartographer, the uncharted waters of Europa, Enceladus, and beyond are no longer out of reach. The question is, what will we find when we dive in? Exploring the alien oceans beneath icy moons isn't just a scientific challenge, it's an engineering one. These environments are among the harshest in the solar system, with temperatures plunging to hundreds of degrees below zero, crushing pressures, and intense radiation from nearby gas giants. So, how do we build AI systems that can not only survive but thrive in these extreme conditions? The answer lies in a combination of cutting-edge materials, innovative power sources, and robust communication systems, all designed to push the boundaries of what's possible. First, let's talk about the materials. Traditional electronics would freeze, crack, or fail under the extreme cold of Europa or Enceladus. That's why scientists are developing new materials that can withstand these punishing conditions. For example, some probes are being built with advanced alloys and ceramics that remain flexible and functional even at cryogenic temperatures. These materials aren't just tough, they're also lightweight, which is crucial for missions where every gram counts. And then there's radiation shielding. Icy moons like Europa are bombarded by intense radiation from Jupiter's magnetic field, which can fry electronics in a matter of weeks. To combat this, engineers are using radiation-hardened components and shielding made from materials like tantalum, which can absorb and deflect harmful particles. But materials are only part of the equation. Powering these AI systems is another major challenge. Solar panels, which work well on Mars or the Moon, are useless in the dim light of the outer solar system. Instead, missions to icy moons rely on radioisotope thermoelectric generators, or RTG, which convert heat from decaying radioactive materials into electricity. These power sources are incredibly reliable, providing steady energy for decades, perfect for long-duration missions. And for underwater drones, scientists are exploring innovative solutions like fuel cells or even harnessing thermal energy from hydrothermal vents. The goal is to create systems that can operate autonomously for years without needing a recharge. Communication is another hurdle. How do you send data back to Earth from an ocean buried under miles of ice? One solution is to use relay satellites orbiting the Moon, which can receive signals from underwater drones and transmit them across the vast distances of space. But even then, the data has to travel through ice, water, and vacuum, a feat that requires advanced signal processing and error correction. AI plays a key role here, optimizing data transmission to ensure that every precious byte makes it back to Earth. Of course, no system is perfect, and that's where redundancy and adaptability come in. AI systems on these missions are designed with multiple backups, so if one component fails, another can take over. But perhaps the most impressive feature is their ability to adapt. These systems can learn from their environment, adjusting their behavior to overcome unexpected challenges. For example, if a drone encounters a thick ice layer, its AI might analyze the obstacle and find a new path, all without human intervention. This adaptability is crucial for missions where help is millions of miles away. Overcoming these challenges isn't just about exploring icy moons, it's about paving the way for even more ambitious missions. The technologies developed for Europa and Enceladus could one day be used to explore the subsurface oceans of Titan, or even the frozen oceans of distant exoplanets. Each breakthrough brings us closer to answering one of humanity's biggest questions. Are we alone in the universe? And as we push the limits of what AI can do, we're not just exploring alien worlds, we're redefining what's possible in the quest for knowledge. So, what's next? The possibilities are as limitless as the cosmos itself. What if the first signs of extraterrestrial life aren't little green men, but something far smaller, microbes thriving in the dark, icy depths of an alien ocean? This isn't just a possibility, it's one of the most exciting prospects AI could uncover in its exploration of icy moons like Europa and Enceladus. Imagine an AI-powered probe detecting a cluster of microbial life near a hydrothermal vent, a discovery that would instantly rewrite the story of life in the universe. But microbes might just be the beginning. What if AI finds evidence of more complex ecosystems with organisms adapted to survive in environments we can barely comprehend? The implications would be staggering, not just for science, but for how we see ourselves in the cosmos. Discovering extraterrestrial life, even in its simplest form, would be one of the most profound moments in human history. It would prove that life isn't a fluke of Earth's unique conditions, but a universal phenomenon, capable of emerging in the most extreme environments. This could reshape our understanding of biology itself. For example, if life on icy moons uses a different chemical basis than life on Earth, say, relying on methane instead of water, it would challenge everything we thought we knew about the building blocks of life. And what if AI uncovers organisms that thrive without sunlight, using chemical energy from hydrothermal vents instead? These discoveries could open up entirely new branches of science, inspiring breakthroughs in fields like astrobiology, biochemistry, and even medicine. But it's not just about life. These alien oceans could also hold resources that make future human exploration and even colonization possible. Water, for instance, is one of the most valuable resources in space. It's not just essential for drinking. It can be split into hydrogen and oxygen for fuel, making it a potential refueling station for missions deeper into the solar system. And then there are minerals. Icy moons might contain rare elements or compounds that could support long-term human presence, turning these distant worlds into stepping stones for further exploration. Imagine a future where Europa or Enceladus becomes a hub for scientific research, mining, or even tourism. The possibilities are as vast as the oceans themselves. Of course, the impact of these discoveries wouldn't just be scientific or practical, it would be deeply personal. Finding life beyond Earth would remind us of our shared connection to the universe, sparking a sense of wonder and curiosity that transcends borders and cultures. It could inspire a new generation of explorers, scientists, and dreamers, eager to push the boundaries of what's possible. Think about it. The kids watching these missions unfold today could be the ones leading the charge to explore distant worlds tomorrow. And who knows, the discoveries made by AI in these alien oceans might just be the spark that ignites humanity's next great adventure. So, what's next? As AI continues to push the limits of exploration, the mysteries of these icy worlds are closer than ever to being unraveled. Whether it's microbial life, complex ecosystems, or valuable resources, the discoveries waiting beneath the ice could change everything we know about the universe and our place within it. The question is, are we ready for what we might find? But as we push the boundaries of exploration, we also have to ask ourselves, what are the risks? What happens if, in our quest to uncover the secrets of these alien oceans, we accidentally contaminate them? It's a question that keeps scientists up at night. These icy moons are some of the most pristine environments in the solar system, untouched by human hands or any hands for that matter. Introducing Earth-based microbes, even unintentionally, could disrupt ecosystems we don't even understand yet. Imagine discovering life on Europa, only to realize it was something we brought with us. That's why missions to these worlds are designed with extreme care, using sterilization techniques to ensure that every probe, every instrument is as clean as possible. But even with these precautions, the risk remains. How do we balance our desire to explore with the responsibility to protect? And then there's the bigger question. What if we find more than just microbes? What if beneath the ice there's intelligent life? It's a long shot, but not impossible. The discovery of intelligent extraterrestrial life would be one of the most transformative moments in human history, but it would also raise profound ethical and philosophical questions. How do we communicate with a species that might think, feel, and perceive the universe in ways we can't even imagine? What rights would they have? And perhaps most importantly, how do we ensure that our presence doesn't harm them? These aren't just hypotheticals, they're questions we need to start grappling with now before we make first contact. These missions also force us to confront our place in the universe. For centuries, humanity has seen itself as the center of everything, the pinnacle of creation. But what if we're not alone? What if life is common, scattered across the cosmos in forms we can barely comprehend? The discovery of even simple life on an icy moon would shatter that illusion, reminding us that we're just one small part of a much larger story. It's a humbling thought, but also an inspiring one. It challenges us to think bigger, to see ourselves not as the rulers of the universe, but as explorers, learners, and stewards. And that brings us to the heart of the matter: responsibility. Exploring these alien oceans isn't just about satisfying our curiosity, it's about doing so thoughtfully, with respect for the worlds we're entering. That means designing missions that minimize harm, sharing discoveries openly with the global community, and ensuring that the benefits of exploration are felt by everyone, not just a select few. It's a tall order, but it's one we have to meet if we want to explore these worlds in a way that's ethical, sustainable, and truly meaningful. So, as we stand on the brink of these incredible discoveries, let's not forget the bigger picture. The exploration of icy moons like Europa and Enceladus isn't just a scientific endeavor, it's a journey that challenges us to think deeply about who we are, what we value, and how we want to engage with the universe. The answers we find might change everything we know about life, the cosmos, and ourselves. But one thing is certain, the way we explore matters just as much as what we find. And that's a responsibility we can't afford to ignore. What's next for the exploration of these alien oceans? The future is already taking shape, with missions on the drawing board that promise to push the boundaries of what we can discover. Take NASA Europa Lander, for example, a mission designed to touch down on Europa's icy surface, drill through the ice, and send a probe into the ocean below. This isn't just science fiction, it's a real possibility within the next decade. And here's the kicker, AI will be at the heart of it all. From navigating the treacherous terrain to analyzing samples in real time, AI will play a critical role in making this mission a success. But it's not just about NASA. Around the world, space agencies are teaming up, pooling their expertise and resources to tackle the challenges of exploring these icy worlds. Imagine a future where the Europa Lander is just the beginning, with international collaborations launching missions to Enceladus, Ganymede, and beyond. And the technology behind these missions is evolving at an astonishing pace. Quantum computing, for instance, could revolutionize how we process the massive amounts of data these missions generate. Unlike traditional computers, which process information in binary, ones and zeros, quantum computers use qubits, which can exist in multiple states at once. This means they can solve complex problems in seconds that would take conventional computers years. For alien ocean exploration, this could mean faster analysis of chemical data, more accurate mapping of underwater environments, and even the ability to simulate entire ecosystems to predict where life might exist. It's like giving scientists a supercharged tool to unlock the secrets of these hidden worlds. Then there's the potential of advanced neural networks, AI systems that mimic the human brain's ability to learn and adapt. These networks could enable probes to make decisions on the fly, adjusting their strategies based on what they encounter. Imagine a robotic drone exploring Europa's ocean, encountering a hydrothermal vent it wasn't programmed to study. With advanced neural networks, it could recognize the vent's significance, collect samples, and even decide to explore further, all without waiting for instructions from Earth. This level of autonomy is crucial for missions where communication delays can stretch to hours or even days. But what could these future missions achieve? The possibilities are mind-blowing. Picture an AI-powered probe discovering a thriving ecosystem beneath the ice, complete with organisms that challenge our understanding of biology. Or imagine a quantum computer analyzing data from Enceladus and uncovering evidence of complex organic molecules that hint at the building blocks of life. These discoveries wouldn't just answer the question of whether we're alone. They could rewrite the textbooks on how life begins and evolves. And let's not forget the potential for human exploration. While sending people to these icy moons is still a distant dream, AI could pave the way by identifying safe landing sites, mapping resources, and even building infrastructure for future missions. Imagine a future where humans and AI work side by side, exploring the depths of Europa's ocean or setting up research stations on Enceladus. It's a vision that's closer than you might think. So, what's on the horizon? As AI continues to evolve, so too will our ability to explore these alien oceans. From quantum computing to advanced neural networks, the tools we're developing today will shape the missions of tomorrow. And with each breakthrough, we're not just exploring new worlds, we're redefining what's possible. The question is, what will we find when we get there? The answers could change everything. As we wrap up this journey into the depths of alien oceans, let's take a moment to reflect on what we've uncovered. From the icy moons of Europa and Enceladus to the cutting-edge AI technologies poised to explore them, we've seen how science and innovation are converging to answer one of humanity's most profound questions: are we alone? These hidden oceans, with their potential for life, energy, and resources, represent a new frontier in space exploration, one that's as mysterious as it is promising. And at the heart of it all is artificial intelligence, a tool that's not just enhancing our capabilities but redefining what's possible. We've explored how AI can navigate the extreme conditions of these icy worlds, from crushing pressures to freezing temperatures, and how it can analyze complex data to detect signs of life. We've seen how it's helping us map uncharted oceans, uncover biosignatures, and even make split-second decisions millions of miles from Earth. But perhaps the most exciting part is what lies ahead. With missions like NASA Europa Lander on the horizon and technologies like quantum computing and advanced neural networks in development, the future of alien ocean exploration is brighter than ever. The discoveries waiting beneath the ice could transform our understanding of life, the universe, and our place within it. Imagine finding microbial life thriving in the darkness of Europa's ocean, or uncovering complex ecosystems on Enceladus. These discoveries wouldn't just answer the question of whether we're alone. They could rewrite the rules of biology, inspire new technologies, and even pave the way for human exploration beyond Earth. But with these possibilities come responsibilities. As we venture into these pristine environments, we must do so thoughtfully, ensuring that our curiosity doesn't come at the cost of harming the very worlds we seek to understand. So, what's next? The mysteries of alien oceans are waiting to be uncovered, and AI is leading the way. But this isn't just a story about technology or science, it's a story about us. It's about our endless curiosity, our drive to explore, and our desire to connect with something greater than ourselves. And that's where you come in. Stay curious, stay engaged, follow the latest developments in this exciting field, because the discoveries of tomorrow are being shaped by the questions we ask today. The universe is vast, and its secrets are waiting to be revealed. Who knows what we'll find when we dive into the depths of these alien oceans? One thing's for sure, the journey is just beginning. So let's keep exploring, keep dreaming, and keep asking the big questions. Because out there, beneath the ice, the answers are waiting. And with AI as our guide, we're closer than ever to finding them.